Okay, in this video, we'll discuss the reasons around circle geometry. But before we dive into the theorems around circle geometry, let's just go through a few basic definitions. Number one is the radius. The radius of a circle is the distance from the center of the circle to the circumference of the circle. Number two, we have diameter. So diameter, people try and memorize it, that it's twice the length of the radius, which is true, but it's also the line dividing the circle in half. So it's a line from one point of the circle going through the center of the circle to another point on the circumference. And that is called the diameter. And number three is a chord. Now a chord is a line between 2 points on the circumference of the circle. The difference between a chord and a diameter is the diameter runs through the center of the circle and the chord is just between 2 points on the circumference of the circle. Next up, we have the word arc. An arc is the line that represents the circumference of the circle between 2 points. So in this case, we have the points A and B on the circumference of the circle. And then we have arc AB. So if I say arc AB, it means the circumference of the circle between points A and B. And if I say chord AB, it means a straight line between those 2 points. Okay, number 5 is a segment. A segment, it's a part of the circle between the arc and the chord. So that is called a segment. And you can also have a sector. So a sector is when we cut to the middle of the circle. So it's like a pizza part, so it'll be cut up. So this is called a segment. This is the area between a chord and an arc of a circle. This big side as well, this is also a segment. And then we have our sector. At number 6, we have a tangent. A tangent is simply a line touching the circumference of the circle. Now, normally, pupils would learn the theorem in terms of number, theorem 1, 2, 3, up until 9. But I'm going to show you more than the 9 theorems that you have learned in school. I'll also show you the converses and the different ways in which they can appear. So first off, we have the tangent to a circle is perpendicular to the radius of the circle. So we have a line that is tangent. That's the tangent to the circle. And we have a radius. And what this theorem is saying is that these 2 lines are perpendicular to each other. So OS is perpendicular to RS. And the reason that we use is the tangent is perpendicular to the radius. So tan, perpendicular, radius. Alternatively, we can say that angle OST is equal to 90 degrees, and it has the same reason. Tangent is perpendicular to the radius. Next up, if a line is drawn perpendicular to a radius at the point where the radius meets the circle, then the line is a tangent to the circle. So this is the alternative to what we have just seen. So what it is saying is, if a line is drawn perpendicular to a radius up until the point where the radius meets the circumference of the circle, then this line is a tangent if it meets the circle or the radius at 90 degrees. So we are given that OBC is equal to 90 degrees. Therefore, we can conclude that AC is a tangent. And the reason why it's a tangent is we say the line is perpendicular to the radius. Alternatively, we can say converse of the tangent perpendicular to the radius. So remember, this line wasn't originally given as a tangent. But because it's meeting the radius on the circumference of the circle at 90 degrees, now it becomes a tangent. And I've proven a tan perpendicular to radius, therefore I say converse. So what the word converse means is I have discussed or given a reason why this is a tangent perpendicular to the radius. The third one that we have for today is the line drawn from the center of a circle to the midpoint of the chord is perpendicular to the chord. So if I have a line that I draw from the center of the circle, that's the line OB, and that line meets a chord, that's the chord AC, in its center. So B is the middle of the chord AC. Then this line OB is perpendicular to the chord. So we are given that AB is equals to BC, and also that O is the center of the circle. Therefore, the angle OBC is equal to 90 degrees. And the reason is line from center to midpoint of the chord. It's important to have the right reason when we apply them in our assignments, tests, and examinations. Now our fourth one reads similar to the previous one. It says, the line drawn from the center of the circle perpendicular to the chord bisects the chord. Now it is the other way around. It is saying that if this line meets a chord at 90 degrees, then it cuts that chord in half. So in the previous example, we had AB is equal to BC, and therefore B is equal to 90. Now we have it the other way around. We are given that the angle B, or OBC, is equal to 90 degrees. We are given that AC is a chord, and that's the center of the circle. And because it meets the chord at 90, it is cutting that chord in half. So the reason is line from center perpendicular to the chord. And in our previous example, the other way around, when we had it backwards, the reason was line from center to midpoint of the chord. So be careful. We are given that this line is perpendicular, so in our reason we say line from center perpendicular to the chord. And in the previous example, we were given that the line from the center bisects the chord, so we say line from center to midpoint of chord.